Hello, everyone. So today we're going to be talking about the week 2, the rest of the stuff. We had already covered the intermediate scripting and things in our project here from the previous lecture. Before we get started with today's content, I'm going to organize the assets in this a little bit so we can import and continue right in this same project without having to create a brand new one. So what I'm going to do is I'm going to rename this scene since it's just the sample scene that was added by default. And we're going to just say file and save as to save the new scene file. I will save it in the scenes folder. That makes a bit of sense. We'll give this a file a name. This will be basics and intermediate. All right. So our scenes now shows 2. I'm going to just get rid of that old sample scene since we just created this as a new one. And we'll make sure that everything is still all working. Yep, they're all running through and they get destroyed by hitting the little blocking pickup that we have or the hazard that we set up. And then what I'm going to do is just take all of these assets and put them in a new folder. We'll just call this week 1. Yeah, we'll just say it's all week 1 stuff, even though some of it's technically week 2. And of course, I have Discord still open. One moment, please. There we go. We'll also put our scenes folder in there. And we'll just save all. All right, so now we have everything wrapped up in this week 1. Ideally, I'd make a script folder, a materials folder, things like that. But for our purposes, I just wanted to separate out that project. So taking a look at some of the stuff we haven't covered yet, there is a portion of week 1 that we never covered, that experiment for state machines. We'll recreate that real quick just to cover all our bases there, and then we'll be moving into this week's content for the state machine stuff. So that experiment introducing you to state machines has you set up one of the most basic state machines. So we'll go ahead and create a new folder here. Nope, not a C# script. That'll be in a moment. Yes, I want to delete it. We will create a folder and we'll give this a name. We'll just say state machine basics. And we'll put all our content for this one inside this folder. Here, we'll go ahead and create a new scene. New scene. Save this in that folder. State machine basics. And this is state machine basics. All right. Let's go ahead and add just a couple of objects similar to how the experiment had it set up. We'll just create a cube. We'll put that the origins, or we'll be able to see it in here. I'm going to just move my camera up a little bit so we see the top edge of it, because we will be working with a light on this. There's a couple of things we can do. We can add light components straight to this, but I want to be able to move it outside of the box and things, so we'll be adding a new child here, just attached to the cube. Pull it up out of the box, and this will just have a light. We'll just be using a point light for this, and just to make it a little bit more obvious, we'll have it be red. Also pull it in front so it highlights the front of the box here. And next up, we'll give this light object, we'll actually call it just light obj for light object. Our cube itself, we'll say, is a lamp. Lamp. All right. And then in the lamp, I'm going to actually put a script that'll detect an input press and switch the lamp on or off. So we'll create a script. We'll just call it lamp. All right. Inside our lamp, we're going to need a reference to that light component. So what I'm going to do is just make a serialized field so I can set that in the editor. Serialized field for a light. We'll call it light COMP for light component. Initialize it to null encode. And then we'll need to do a couple of things. I mentioned that I want to turn this light on or off based on a key press. So inside our update, we can set this up all right here. If we press a key, input dot get key down, and we'll use the space key code dot space. When we press it, we'd have to ask if the light is on or if our light component is enabled. If that's true, then we could turn it off. Light comp enabled equals false. Else, that means that light component enabled is returning false. We'll go ahead and tell it to turn the light on. And this is a very simple setup, just because we're only got the binary of whether it's on or off. We'll be converting this over to a state machine, and then because we'll just be using this as the very simple example. We'll go ahead and save this. Make sure to attach lamp to our lamp object. Last thing I need to make sure is to assign that light component, because it needs to know which light it's talking about. There is only one, so we could technically find it in the level using like either its name or anything like that, but by actually assigning it here, that gives us a little bit more versatility if we add more lights and things. So we press play, and we press space, and we do see that it is working. So if we wanted to convert this to a state machine, because right now we are doing everything in update. So every update, it's running all this code, always checking space, always checking if it's enabled, or if it needs to run this code and things like that. And for a simple thing like a light, that makes a little bit of sense just to keep it this way. But if we wanted to set it up more modular and say we have 15 different states that we would need to check, all of those would complicate this if and else if chain quite a bit if we had more and more states, and everything would all be an update running constantly. And that just adds a more complex setup than we really need. To try and track down errors in the logic, there would be a lot of if and else ifs to try and chain through. So we'll change this over to a state machine method. And what we'll do is we'll actually set up a simple or very simple state machine here. We'll be holding a dictionary of different states and things. So we're going to need an enum well, we don't need an enum for states, but it's going to be easy to do that. So we'll just call this lamp states. And our first one will be on. Our second one will be off. And then just a common thing for enums is at the very end, they just have size listed or count. So we'll just call this count. And then our dictionary will pair each one of these lamp states to an actual function that it can call. So we'll be pairing the lamp state as the key, and our actual value that the dictionary will be holding is a function. So there's this keyword called action, or shoot, what is it called? It is action delegate. That's inside certain under system. Oh, so this one is not just using system. Okay, so we'll make sure to check that out, add that using statement, and then we have that keyword action. And what that is it allows you to use a function like a variable. So we'll pair those two things together. We'll give this a name, FSM for finite state machine. And we'll initialize this to a new dictionary. And then we can add different states to this. We only have the two, so it'll be pretty simple. I'm going to set up a separate function for each one of these to run when they're active. And we can do that function even right up here. We'll do, we'll keep no return, void, and we'll just call lamp on. And this will be running when it's in the on state. And then we'll have one for lamp off. So we got our two functions. And in start, we'll actually populate our dictionary with these two different states. FSM.add. What are we going to add for the key? First key will be our lamp states on. And our actual function that we're pairing it with is our lamp on. And our next one will be just about the same line, but it'll be pairing off with our lamp off function. Lastly, we need a variable, well, not lastly, but we need another variable to track what current state we're in. So we'll create a lamp states variable, and we'll just call it cur state. And we'll go ahead and initialize that to the lamp on, lamp states dot on, and got a question. When making states, do the states have to be in all caps? That's actually a great question. Whenever you're using an enum, it's very common that the actual terms that you put in the enum are all caps. It's just a habit that I've gotten from programming. And so oftentimes when you're talking about an enum, it's very often in all caps. This is actually technically an enum right here, and that doesn't follow that. So it is really just up to you how you want to name it. It doesn't have to be. I like to separate it out because if I see all caps, I know, oh, that's an enum. But that's just a code I picked up, or a habit that I picked up. So we've got our current state, and in here, we can now have separate code running for when our lamp is on or versus when it's off. So there's a few different things we can do. We want to make sure that our update function, it was running all this code before. I'm going to comment that out. And our update now will just be running the function from its current state. FSM, we will call sub current state, or cur state is what I named it. We will be invoking it, which is another term for calling that function. So our update no longer will have a complex if and else ifs and all that. And each state, when it's currently in that state, can do what it needs to do. When we're in the on state, we'll need to be checking if we press a button and turn it off. So let's add that code. If our input get key down, key code space. When we press that, we'll have it change the current state to off. So not only change the current state off, but actually tell the lamp to shut itself off. So cur state is going to go to the off state. And we'll make sure that it shuts the light off when it does this transition. So that's where this transition portion comes in. We're checking for how to exit this transition. We're only exiting if this space key was pressed. Then we'll do some stuff, set it up for the off state. And our for off, we want to make sure to set the light off, just like we were doing below. And then it's good to go. And if our light is in the off state, we'll be doing pretty much the exact same thing, just the opposite, since it's only a binary on or off. We'll take a look at adding more complex in a moment. If we press space when it's off, we'd want to turn it on. And each individual function now only needs to focus on what it needs to do when one of the exit transitions or one of the transition conditions is met. So we'll save that. And we'll make sure this is all working. So I press space. And from an end user standpoint, we don't see any difference. It's working just like it was before. But from a code architecture standpoint, it's much easier now if we wanted, say, a third state. We can tack on a third state. We'll just say this one is change color. We'll create another function for what it does when it's in the change color state. Good. Lamp, change color. And whenever it's in this state, I want it to continuously change colors. So keep in mind that each one of these functions will be called every single frame because our update's just updating our invoke whenever the current state is set to that. So for our change color, we'll go ahead and get our light and we'll get the color and we'll be setting it to new vector 3. We'll do, is there a random unit vector from this? Probably is. Vector 3. I won't come up with a random, darn. New vector 3. Random We have to create an instance of that one, don't we? What one does this have? Does it have any general stuff? No, just an equals. Great. Create a random object so we can get some random numbers in here. It's getting a little bit more complex than I wanted, but we'll just call our random number generator R. Oh, and you can't create it because ambiguous reference. Oh, from system random. Goody. System random does have some functionality. R. Give me one moment. There we go. So now we can ask R for its next float. We'll use double, I guess. And we'll cast that to a float. So a bit more complex than I had wanted, but just know that this is going to create a random value. Random values for the colors. We have 3 different colors to set for the RGB and RG and B values. And next double. And what I'm doing with this float casting is we're converting it from a double to a float because vector 3s do require floats. And what is this complaining about now? Cannot convert from vector 3 to color because this is a color, not a vector 3. That would make more sense. There we go. And we're getting 3 random floats for the R, G, and B values. And that with a semicolon. And our next thing we'll do is we need a way to transition to this state. Let's say we can only go into this lamp change color state from our on state. So on can transition to the off state as well as if we press a different key, input, get key down, key code, let's say P for party mode. We'll go ahead and tell it to change the current state to the change color mode. Save that. And if we play, I'm going to turn the light off first. And if I press P, nothing happens. So we can't activate party mode from our off state. We press space, we turn that light on. We press P now, oh, we get a null reference exception. Fantastic. Key's not present in the dictionary. Whoopsie daisy. I forgot to actually add it to the finite state machine. So in our start, when we were initializing everything, we added the on and off states, paired those with a specific function. We also need to pair our change color state to the lamp change color function. Save that. Play now. And as we can see, pressing P in the off state does nothing. I press space, it's on again. And if we tap P, now it's in party mode and just changing colors every single frame. All right. So what this allows us to do is actually control what states it's going to transition to and each state individually, when it's checking, only needs to check what can it actually transition to. Right now, it goes to lamp change color, and we don't have any exit condition or transition to any other states. We could set that up here if we want it to allow it to go back to the other things. And love to make mistakes during the lectures. Yeah, I absolutely do. Just it's super common. Even years and years of coding, you'll forget one little thing. Just being able to see where those errors are and actually exposing you to that. And I try and do a couple of them on purpose to kind of point that out and let you guys know it's very common. All right. So we've got that all set up. And were there any questions about that week one, the state machine example that they had you set up? Or anything like that before we move into this week's state machine stuff? No questions. All right. So we're going to move into this week's stuff. There is this discussion post right here. Most prevalent error, forgetting the semicolon. Yep, that's super common. And luckily, the IntelliSense usually points that out now, like you're forgetting that, and just give it one moment, lets you know, like, hey, there's this error on this line, or hey, semicolon expected. So it's pretty good about pointing you to that one, and very common mistake though, for sure. So back to this stuff. So the discussion post. This one's asking you to take a look at some games that you've been playing recently, or you've been following along with playing them and things like that, and kind of think about this mentality of what would be considered a state and what other exit conditions could that state have to go to the other states. So really taking a look from that game designer perspective and analyzing, well, what is a state and things like that. Keep in mind that there is no real right or wrong answer. This is just a thought process or a thought experiment. So if you list maybe 20 different states and somebody other lists 10 different states, even if you're talking about the same type of game, there isn't necessarily one is right, one is wrong. It's more just getting in that mindset of thinking about what could be considered a state and why would that be considered a state, what other states can that transition to, always thinking in that mindset. So big one to focus on is make sure you're actually talking about those exit conditions that it would need to check for while it's inside one of those certain states. So for example, in our code here, when it was off, the only exit condition it could go to was on. When it was in the on state, we could turn it off again, or we could actually activate party mode. These would be considered the transitions. It would go to this other state, this change color state, or the off state from lamp on, based on just these simple key presses. All right. So out of this experiment, or the discussion post, I do want to talk about this little thing about reading, and there's a couple of videos just talking about several different state machine setups. It goes over the Mealy-Moore machines as well as the Harrell state machine, and there's a lot of different models of state machines in general. And then at the very end, it relates it back to games themselves for this book called Game Programming Patterns, Design Patterns Revisited. This is actually one of my favorite programming books for game programming patterns. The entire book itself is actually available on this website. I do recommend that you bookmark this and explore it further beyond just the state machine that's demonstrated here. And give that a read through just anytime you want to. As we can see, here's the individual states and then the transitions to the other states describing what has to happen for that condition or the exit condition to be met. Things like that. So it does a great job of explaining other different design patterns as well, not just the state pattern. All right, so that's a research assignment, and next we get up to the experiment. So experiment, we're going to get our nav agent working with a state machine as well. The state machine you'll actually be working with is one that we've provided for you. So you're going to be downloading this package and getting some exposure to working with something else that someone else has built. So learning how to use an external API. So we're going to download that and just kind of explore it together a little bit today. You'll also need to run through the experiment itself. But we'll take a look at it and go through that a little bit today in some different context. So in here, the experiment itself, as I mentioned, you'll want to run through it, and it will talk about how the states are set up and things like that. And then it'll go on to actually have you add a pause state to the thing. So I figured today in lecture, we'll add another state, just not pause, just to give you another idea of how things can be set up. So I've downloaded that package here. I'm going to just extract that. And we'll be dragging and dropping this package into Unity. Oh, and of course I don't have the project folder open. All right, and shows us what it's going to import. We'll import everything. And there's several different folders. It's added a whole bunch of stuff. So in here, we're getting a warning, and I can't see it because of these meeting controls. Hide meeting controls. Namespace already contains a definition for nav point. Ah, right, because my week 1 stuff, we named it nav point as well. Well, crap. The nav point script doesn't have like anything in it. So I'll just get rid of one of these because they're going to be the same. So, meh, goodbye. Next up, we have these 4 numbered folders here. So ideally, you'd start from a different project. I wanted to try and organize it in this project. I'd forgotten that last week I did create that nav point script. But if you do have anything named the same, you will have to either rename it or resolve that naming issue. Otherwise, the code won't compile. Okay, cool. So we have 4 named folders, or 4 numbered folders right here. Nav agent better, nav agent even better, and nav agent best. Inside each one of these folders, there's a scenes folder, and there's a scene called nav mesh. Problem we have is each one of these folders all have the same name for the scene. Now I say that's a problem because if we just go ahead and like open up this one, I don't know which version I'm in, what scene am I in currently, other than I just opened it up, but it looks absolutely no different from the scene view than the other scenes. So I'm going to go ahead and rename these. So the one inside our 1 folder, I'm going to put a 1 after it, just to make sure that I know what that scene is. Our 1 in the 2 folder, we're going to put a 2 after it. Our 1 in our 3 folder, you guessed it, we're going to put 3 after it. And in 4, our final one, we'll put a 4 after that one, just so I can make sure that I'm in the correct scene and I don't accidentally start working in the wrong scene when it tells me to add that other state and things. All right. There's, other than the named folders, or the numbered folders, I keep saying named folders. We have another folder named FSGDN. Inside here is where an actual state machine's set up. Now this state machine's much more advanced than the basic one we had just written in that one single script. And it uses interfaces and inheritance and has some error checking code and stuff in there. So you might not understand all of the things that it's doing at first, but I do recommend you kind of open that up and kind of explore the actual state machines itself. For example, this is our state class. It's all inside a namespace. It inherits that state interface, so it has some basic functionality of being able to execute, physics execute, on animator IK. You won't really be using that for this class, but it's there in case in future versions you'd like to use it. Then there's a few different macros and stuff here to add some debugging logging to actually say every time a state changes. It even can comment that out to make the state machine quiet while it's running, but we'll leave it on for now just so we can see each one of those state changes and things. So it's very common in the industry that you'll be working with other people's code, not just code you've written. We want to try and give you some exposure to that by providing you with this state machine and having you work with it and be able to add your own states and change states properly. So let's just jump into these named scenes and start taking a look, kind of breaking down how they're set up. So for our nav mesh 1, or our basic nav agent, we go ahead and press play. You see our nav agent goes to the nav points, pretty much the end result of what you should have had for the previous experiment here. If we actually look at our nav agents here, we'll see the script and we can open that up. We have the array of nav points set up in the editor here. And this is a finished version, just in case you were having troubles with the previous assignment. So let's dive into the next scene, nav agent better. Well, what makes it better? Well, let's explore it and find out. So from a playing standpoint, press play, starts moving through. It's actually pausing now at each one of the nav points, waiting a little bit. Our console is actually initializing states. We see it enter, exit states. So there's a patrol state as well as an idle state. It's in patrol when it's moving, then when it hits one of those, switches to idle. Let's see how this script was set up. We look at our nav agent. It's not just one script. There's a nav agent better as well as a state machine script. So let's explore this. So we have our agent better, and just a note, you can have your solution explorer and explore your different files here without having to jump back to Unity. If you don't have your solution explorer open, under one of these, it's view, I believe, solution explorer, or you can use Control Alt and L. We can now explore the scripts this way and open up that other script that we're using for this one, the actual state machine. From a viewpoint of the better, We can take a look at this. We see it's pretty much working the same way, but this one has some comments in here that they changed the actual protection level of this to public, so it can be called from outside the class. Instead of calling find destination to pick the next nav point, it actually tells the state machine to change to an idle state. So these two scripts are working together. We see in the state machine script, there's lots of comments. I'm not going to go through and read each one of these comments to you. That take up quite a bit of time, and part of this is to explore some of the code, but there is extensive comments kind of explaining how things were changed from the previous version, because we're currently in 2 versus 1. Let's go back to Unity and take a look at our third state machine or setup. Whoop, that's 4. Number 3, or our even better version. If we press play here, we see this is colored now. And it's actually changing color, giving that player feedback about what states it's in, versus having to have our console open and be like, oh, well, what state did it just enter? What state did it exit? Things like that. Actually having in-game feedback adds a lot. So it is just performing the same thing, but we have that color change in there. Let's take a look at our nav agent, see what kind of scripts this is working with. No longer the separate scripts. So this is now combined into one script, and the script that's attached is just deriving from our state machine in general, and moves over all the other stuff from the nav agent script so that it's in one script, more contained and easier to attach and things like that, rather than managing the 2 different scripts over here. And there's more comments that I recommend just looking through and reading through when you have a moment. So if that's even better, what possibly could best have? We'll open that up. And we are in the other scene, even though it looks the same from this perspective. That's one of the main reasons why I changed that numbers. We play. Looks pretty much the same as our even better script. So no difference from the end user perspective. But let's take a quick look at how things are set up. One script, just like our even better one. But in the script, we see no comments or mentioning anything changed here, but there is a helper function now for changing the object color. If we go to our even better script and see how it was changing color, it had this line right here inside, like each one of the states is how it was telling it to change to a different color. So that's a pretty big complex line. If we go to our idle state and kind of review that here, in fact, I'll dock this one to the right side. This is the even better version. This is our best version on our left, which for American reading, that's a bit backwards. I'll swap those to the different sides for comparison. Old one on the left, new one on the right. We have our idle state right here. This is the new way of changing color. Much cleaner version than having to do this cast, having to get the specific renderer, get specifically the color. We're just calling a function on the state machine itself. So not only does it clean up that code and things like that, each one of the states, rather than inheriting from a basic state, we're inheriting from this new nav agent state. And that nav agent state inherits from the basic state, but it does add this accessor function for easy use to get state machine access from inside the individual states. So we can kind of see how this code evolved and how it got better and better each time. And make sure you do actually read through all the comments so you have a little bit more understanding of how that's all working. The other thing we'll do, I want to point out that from this one, or even better is probably one of the best references to read to see how things are kind of working. Brought that over from our nav agent script. Machine behaviors, this first class start gets things set up. Whether add states gets called, so we need to make sure that we are calling that parent function so the state machine runs. The add states is where it populates the state machine. Just like that very simple state machine we had set up inside our lamp, we had to, inside start, make sure to add each one of the states. Well, the state machine has a function named add states where you populate the state machine. Same kind of concept there. All right. So we've got a state machine set up. We explored a little bit of the code. You can do more exploration on your own. I believe it even guides you through that for the experiment. I just wanted to kind of cover what's included for the package, and then we'll take a look at how we could potentially add another state to this. So we're going to work right in our best state machine. I want to make sure I have nav mesh 4 open because that's our best one. Should have probably just even named it best or something, but hindsight 2020. In here, taking a look at the actual states themselves, here's the entire patrol state. So anytime it's actually like doing the moving in between each one, it's running this code. We have a couple of different functions that got called for each different state. So we have one for when it's first entering the state. Think of this similar to like a start function on a script. When it's told to change to the patrol state, it runs the enter state or the enter function once, or just setting its color and telling it to start moving to the other destination. We don't have any update or anything running inside this patrol state, so it's not actually running any excessive code or anything like that it doesn't need to, or checking what state it's in or anything like that. It just runs code when there's actually like an event changed and it first enters the patrol state. Our idle state, a little bit more going on. We set up a simple timer. When it first enters, sets the timer to 0, changes the color, and then in execute, which actually runs every frame. So execute is similar to an update. So this is, think of execute as it states update. We're actually increasing the time for how much time has passed. If that timer is past a certain point, that's our exit condition to change over back to patrol. So it adds that little bit of delay for our character. Well, I want to add a new state to this. In terms of functionality, we'll take a look at how we can set up a distract state. So for this, I'm going to add an object in here. It's not just one of the nav points, it's going to be a separate object. We'll go ahead and create, we'll go with a cube since there's already spheres and other things in here. And oh my God, I forgot the view on this is, or the scale is way big. So just a one unit cube is really tiny. We'll bump that up a bit. We'll say 3. All right, so we got a cube here. We'll use this as kind of like a distract point. I do want it to trigger because I want to know if the agent, or yeah, nav agent hits that cube. We will be renaming this distraction. And we'll create a simple script for it, just like the nav points. I'm going to just create a new one so we can identify it in code. Distraction. Open that script up. Got the actual class out, since we're just using it for identifying that it is a distraction node. And we've already got it placed in the level. We need to tell our agent about this distraction point. So I'm going to go to the agent script. And way up at the actual script that's attached to the object, we'll add, we already have serialized nav points and a variable to track what our current index is. Just below those other variables, we'll create another serialized field for our distraction. Distraction, we'll just call it a D for short. Initialize to null in code. Save that. Give that a compile. It's assigned but never used. Yes, that is true. What I'm going to do is make sure that in the editor, I do actually assign it to an object, which D, we have to select one of the distractions from our level. So select from our scene. Oh, I don't have any in the scene because I never attached our script to the object. And now that that's attached, we can tell our agent that that is the distraction point we're talking about. All right. Next up, let's go ahead and create a state to have it go to this point. So we'll go ahead and be creating, I'll just add it in between our patrol and idle. One thing I want to point out is that where I'm at and what scope this is, it's actually outside of every other class. There's multiple classes inside this script. This is something you might not have seen before because you're probably just used to working with the one script at a time. But this class up here is the actual state machine class. That's the one that's being applied, the component that's getting attached to our actual object. These other classes for the states are completely outside of that. One good thing to check out is these top bars indicating what your current scope is. Like, are we even inside a function? What class are we in? Project, not so much. You generally won't have too many Unity projects inside one solution. But that class tab can be quite useful to make sure when you are declaring like a new state, we want to be outside every other class. Grayed out means you're not inside a class, you're completely beyond outside of that. The previous class has been closed already. We'll be creating a new class here. Public class. I'm just looking at this one to reference it. We'll give this class the state a name. We'll call it distract state. We do want to inherit from our nav agent states. We got to do a couple of things let's first just get it changing color before we worry about telling it to move to this distract point and anything like that. So we'll handle what happens when it enters this state. We'll look for override, and we can override the enter function. We want the parent functionality to run, and then after that, we'll also just kind of follow that line 71, where we're telling the nav agent state machine to set its main color. And for this distracted state, we'll just go with a red color. All right, so I created this new state. I then need some way to change to this state. Well, inside our actual script that's on the character, the actual state machine, we are only changing state inside the onTrigger enter here. I want to be able to just press a key and tell this agent to move to that new location. So we'll add a, we'll handle the update function. We're going to look for override, our update. Now it's real important that we still have our base update run. That is the state machine's update. That's when it actually checks, should I transition to the next state or things like that. And I'm sorry about that. It's just gonna probably be a little bit irritating right now, but internet's going to do what internet things. So we still want to make sure that the state machine runs its update. We'll run that, and we'll be checking if we press a key, input get key down, key code. We're using distract, so we'll just say when our player presses D, it'll distract our character. So when they press that, it'll enter or change state. As we can see, here's a reference to change state that I'll be taking a look at. Change state. You see it is a templated function. That's what the angle brackets indicate. And which state we're actually changing to gets passed in here as its type. Well, we created the distract state type, or class rather. All right, so that should tell it to change to our distract state when we press D. Save this. Give this a play. I'm going to click on the game window so my input's going there. And if I press D, we got an exception. I'm going to just turn off messages. Oh, state machine's letting us know change state cannot find the state in the machine. Did you add the state you're trying to change to? Well, that's basically our state machine. If we look at what's happening here, it has a bunch of error checking code in it. We told it to change to a state. It couldn't actually, it was getting that key not found exception. If you remember in the basic state machine I set up, I never actually added it to the dictionary, so it couldn't find that key in the state machine. Same concept here. We've added a few different things to try and point you in the right direction. Did we add that state? Well, looking at our script, I mentioned that there is an add states function where it's populating the state machine and telling it which state it's going to start off with. Patrol and idle get added. We also need to add our function, which before I do that, I am still paused right here. With this error, don't just always double click and be like, oh, the state machine's got an error. It's not my fault. Read the error and see if what it's trying to tell you. In addition to that, take a look at where this error is actually coming from. You can actually follow the trace back to code you've written. In our nav agent state machine best is where it's happening on line 59. We see it's coming from where we added that change state code. So don't forget about this lower portion of the actual error explanation. It can really help you figure out where things are coming from and not just show you exactly where the print was happening. All right. So with that, I'm going to close out of the state machine stuff and we'll go to our script, back up towards the top. We do need to make sure that it does get added to our state machine. Add state. Which state? We want to add our distract state. Save that. All right. Give this a play. And we see it's all good. If we press that D key, we got it changing colors. Now it's not going to that specific point yet. So we'll need to add some more code to try and get it moving to that specific point. Well, I know our patrol is telling it to go to our patrol points. So we'll take a look at what that state's doing and seeing how it gets it to move. It's not only setting the color, but it's also telling our state machine or the script that we have attached to find destination. So I'm going to right click and actually see what that function's doing. You can actually use a peek definition to open up a split window in the middle. We see find destinations, getting the nav mesh agent component and setting a destination to the current nav index from the array, getting that position. Okay. So our distract state should do something similar. So I'm going to actually go to this definition where this function is. And we're going to be doing something very similar, but rather than going to our nav point stuff, we have our variable that we created, just D, which should give that a proper name, distract obj. So that's our distract object. And we're going to set up another helper function, just like this find destination. We want it to be public so that our state can actually call this function. Public, we don't need any return. We'll say go to distract point. And we'll be getting that nav mesh agent component and setting a destination. Only part will change is the position that we're actually telling it to move to, or the target that's being passed in. Get component, nav mesh agent, set destination, and where do we want to move? Well, we have something called a distract obj that we've assigned in the editor to be that other object we've placed in the scene. We'll get its transform and its position from the transform. All right, now we need to make sure to call this function. So way back down in the state, when we enter, we're turning it red for the distract. We'll also tell our state machine, nav agent state machine, to go to the distract point. And what that's going to do is start moving to the distraction object's position. All right, let's save this and make sure that it is actually working. Press play. If I tap D, we got an error. Object reference not set to an instance of an object. Well, where is that coming from? Inside our state machine best. It's when we are trying to call go to distract point. The null reference it was talking about was our distract obj. The problem is I had renamed the variable and I never reassigned it. So our agent itself for its distract point was set to none. So that's getting that a null reference anytime it tried to get the position from this object. So we'll make sure to set that again to the distraction object. Give this a play. If we press D, hey, pulled it off of its normal patrol path, and it's navigating over to this distraction point. Now I want it to detect when it hits one of these distraction points and just go back to its normal patrol after it touches it. So what we'll do is inside our on-trigger enter that we have, just like when it touches one of the nav points, it changes to idle. We'll go ahead and add another if here. We'll check the other object if it has a specific component. Component we'll be looking for is distraction. That's the script we've attached to our distract object. So we can now identify when we're touching one of those versus one of the nav points. We'll go ahead and change state. What state do we want to change to? We could go straight to patrol, but I do want it to kind of sit there for a moment once it touches it. So we will just go to idle. No, let's go just back straight to patrol state. Now, because we're working in the project with the several different examples, watch out when you are telling it to switch to another state and things, because the one this state machine is specifically using is the best one, patrol state best. All right, so we'll save that. If we press play and we distract right off the bat, it does change color. Oh, goes pretty slow. Speed it up a little bit. Touched that, and then it's going back to the patrol point it was trying to get to. Now, one thing about this, if for example I press it now, it's trying to touch the distract state, but it hit that patrol, the nav point first, and we see it acting kind of weird. It's touching the nav point, changing colors, still kind of moving to the next point. Now it seems good, but I want it to really only respond when it touches one of these points or the distract points when it's specifically looking for it. If we take a look, we just have on trigger enter. If it touches any nav point, it's going to change to idle. If it touches any distract point, it's going to change to patrol. And I will just put this on one line so we don't have that. But I want to add an extra condition here. I want to make sure that not only if it touches one of the nav points, I want to make sure that it is also in a specific state. Well, there's a function built into the state machine to ask if it is in a current state or is current state. when it's talking about nav points and looking for those, the only time it should ever be really looking to see if it hits a nav point is if the current state is our patrol state best. All right. And the other thing, if we're looking for our distraction, we would want to check if it's in the distract state. So that way, if it ever runs over one while it was just patrolling to another nav point, it just ignores it. Distract state. So adding these extra conditions cleans that up a bit to make it more specific to the state it's in. Now, give this a play, and I'm going to wait till it's about in the center, try and call it so it hits through there. And come back here. Distracted, so it's going towards here. Now it hits that and just ignores it because it's in the distract state. Only responds to that. Oh, we see a little bit of weirdness because right now it still doesn't care which point it's going to. Like, for example, it was trying to get up here, but as soon as it hit this one, it's like, oh yeah, go to the next nav point now, and kind of skipped ever touching that point. There's one additional thing we can do to spruce that up. And right now we're just checking if the other object has this component. The specific one it's navigating to is from our array using our current index. What we can do is say, not only do we want to know if this is non-null, we want to make sure that it is equal to the point we're trying to navigate to. I'll just copy that from right here. So that if it hits one that's just in its path, if you remember when I was first setting up the nav points, I did the same thing for that lecture to make sure that it only cares about the nav point that it's specifically trying to navigate to, and it's in the patrol state. And if it's in the distraction state and hits one of the distraction nodes, then it would change back to just patrol. All right, so that should just wrap this up nicely. Let it hit there, speed it up again. Oh, gotta click the game and distract. Never actually got to that point, so it should try and get to that point again. So we see it and hits that one and just ignores it now. It doesn't try and change to idle when it's hitting a nav point that it's not trying to get to. All right. So that is pretty much it for today. Don't forget to run through the experiment and double check make sure you're aware of the deadlines. This one's not due till Sunday. Let's just take a quick glance at week 2 stuff. The discussion post is due tomorrow, including the intermediate scripting test. And then the next stuff is there. Glad you enjoyed it. Were there any last minute questions before I exit out of this and get the lecture uploaded? All right. Well, I know today's lecture was delayed, so there will be a session open on Friday as well, just for a bit of Q&A if you are working through this stuff and you have a couple more questions or anything like that. There's also a lab session opening up at 7 tonight, in case you want to hop in there and ask questions as well later on, and I will see you later.